Hello everyone and welcome. So in this video we'll be building the staircase asset from start to finish. It will be a nice challenge to test your procedural modeling skills and hopefully you'll get away with some new tips. So yeah, let's get into it. So in a new scene I'm gonna start with this curve that I already have from my other file. It's a Bezier curve. So instead of me trying to replicate, I'm gonna just copy it from the other file. So just draw a curve something like this along the z-axis and make sure it's Bezier to have this nice curvature. From here, I'm gonna resample this and I'm gonna give it 25 segments and output curve view, which is a value along the curve. You already know that probably. Then I'm gonna create in here an orient along curve and I'm gonna save out the n attribute only. So these will be, the normals will be around along the curve as you can see. And from here we can just sweep to create the stairs or the beginning of the stairs. So I'm gonna set these to ribbon and right away I'm gonna change the width to be 0.35 and only 6 segments. 0.35, and I'm also going to reverse it and play in here with the scale ramp. So I'm going to set this to B-spline and change in here a bit the settings. So I'm gonna drop this one down, oops, to about 0.62 or something, and also play in here with this one to get something like this. But in this case, I would like also to rotate a bit this end in here to be a bit more straight, which was closer to my reference. So for that, I'm going to actually manipulate the normal attribute. So let's do that. Let's create in here a wrangle. And I'm gonna manipulate the normals along the curve. So for that, I'm gonna use the curve view. Float u will be equal to the curve view, so the value along the curve. Then I'm gonna create a variable for an angle that where I'm gonna create an angle ramp along the u. Then I just need to rotate it, so for that I'm gonna create a quaternion and I'm gonna rotate the angle and along the y-axis in this case. 0.0. Then it will be simple enough, we just need to rotate it. So v at n, it will be equal to q rotate, and I want to rotate this quaternion and affect the n. This won't do much because we actually need to create the ramp. So let's actually set it to 0, and in here we can start to affect this. Let's change this to B-spline and get somewhere along these lines. So let's see. As you can see, I'm rotating, affecting in here, but I'm gonna be picky and just make sure I only rotate 255 in here. And in here, I'm gonna set it to 36.04. And for this one, I'm gonna set it to 0 on the position 0.1. So something like this. As you can see, I'm rotating just that part. It's a bit, you don't have to do that, but I did it anyways. So now, what we want to do is to round off this front part in here, and for that we will need to output some attributes on the sweep node. So let's look at the sweep nodes, and I'm gonna output in here a few attributes. So I want to output the point call, the prim row, and the prim call. I'm not sure if I'm gonna need them all, but here's the prim call, so an ID for each column. Prim row, we will be using this one, and a point call. In this case is in point mode, so each edge loop in there. So let's create another wrangle to affect to copy the normals from this curve. Since we have the normals, we just want to affect this middle column and pick it a little bit. So let's connect this in here. And now we can do the following. We can copy them. We can only affect the middle column. So at point call is equal to 2. So we're only affecting. So if I do vp.y plus equal point on, we're only affecting this one. In this case, I want to set it to 3. Yeah, that will be better. And what we will do in here, we will create another ramp. Float u will be a ch ramp, and I'm gonna call it u ramp, and it will be along the curve u, because we still have that attribute, as you can see. So curve u, and I want to set the normal to be equal to the op input put 1 normal, so normal from the curve input 1, and I'm gonna multiply it by the u. Let's see how that looks. So I just need to make sure in here that I'm matching by ID. So after the resample, I can create an enumerate and set this to ID and choose points. And let's see those normals. So ID, that's fine. Oh, I need to create the ramp, of course. And now I just want to place them like this, create a B-spline, and just reduce the effect in here, because I just want to affect this front part. Now it's pretty simple. We can create a soft peak, for example. And I'm gonna peak it a little bit, but in this case, I'm gonna choose only this in here. And let's play with the soft radius. So in this case, I want to pick a distance of 0.08 and a soft radius of 0.2 something, 0.245, let's say, maybe a bit more, now that I see it. Yeah, something like this. And now we only affected that front part, as you can see, round it off. Maybe we can pick in here the 2. Yeah, doesn't work so well, so the middle one it is. And you can always play in here with the ramp to affect more or less the other parts. In this case, I'm gonna keep it like this. So for the next part, we will create the stairs. So now we want to separate each stair. So for that, I'm gonna use unique points. But these will separate, if I do an exploded view, this will separate each prim. So what we want to do is to do it by attribute and not normal. I want to do prim row. As you can see, we have that attribute, and now we have separated successfully. Now we need to create an offset attribute to offset the stairs along the Y. So let's create another wrangle, and we will create a step height, which will be a channel that we will control. So step height, and then we create the offset. So float offset will be equal to step height multiplied by the prim row. So I at prim row. And if we assign this, so float offset, and if we have a look at that, and these should be not on points but on primitives, and if we check that and we create actually a value, so we will have this offset along the stairs, and I'm gonna set this to 0.03. But as you can see, it will start from 0, and I want to have some height right at the beginning, so I'm gonna just add 1 in here, and this will be a bit better. So now we can actually offset them. So let's just create another angle, and this one will run on points. So since we want to affect the position, and we can just read the offset, or we can promote it, it's the same thing, but I'm gonna do prim, read it from the prim attribute, offset, I at prim num, oops, and finally we can just do v at p.y plus equals offset, and we get something like this, and we can go back and change the height, and this will be consistent along the way. Alright, now I want to extrude them down, so for that I'm gonna do a poly extrude, and I'm gonna do transform extrude front global and set the y scale to 0, but in this case I want to reverse it, so let's do reverse, and let's do output back, and this is our stairs for now. Now let's just make sure we have a normal. I'm not sure if I created some divisions in here, but yeah, I don't think so. So those are our stairs. Let's create a null, and now let's have a look on how to create the other parts. So for that, I'm gonna output in here before this poly extrude. I'm gonna create in here a null, and from there I'm going to blast some of the prims. So in this case I'm gonna do at prim call is equal from 1 to 4, and I'm gonna delete. I just want to keep the outside ones, as you can see. Then I'm gonna extract centroid and do it on primitives. Then just for fun, let's add a point cheater to not be so perfect, and make sure we don't displace them along the y, just on x and z. Do a scale of 0.02 something, and we can play with the seed, let's say 3.45. Oops, 3.45. So let me actually increase this. Yep. So as you can see, we're just playing a bit with the position of those points. Then I'm going to create an enumerate on points. And finally, we can copy them to the top. So copy and transform. Let's copy them along the y of about 0.15. Finally, we can add them. So with an add node. And let's do by group, by attribute and index. And here we have this part. And for the other side, we can actually, to create the top part, we can blast from this half of it. So in this case, we can blast from 0 to endpoints, to half of the point, so endpoints of the incoming geometry divided by 2, and we subtract 1. So we get only the top points. Then we can add by group, and in this case we want to do skip every endpoint to create this geometry. And from here we can just resample, and I'm gonna set it to about 0.025, something like this. And also on the other side we need also to resample by the same amount, so that's fine. We can just copy, and we have something like this. Now we can simply sweep this with round tube, and let's also do grid for the end cap. And in this case I'm gonna set a value of 0.007, and I'm gonna copy this in here and do a value of 0.01. So we can get both and do a sweep and create and do a merge, create a null, and that's our progress so far. we still have a lot of work to do, so let's do that in the next part. So if we look at the normals of our geometry, we definitely can see this faceting effect, which is not ideal, so we need to rebuild part of the geometry in here and only keep the stairs. At least was the way I found it worked better. So for that, after this wrangle in here, where we manipulate the normals, I'm gonna create yet another sweep. And this time I'm gonna just remove all the columns and just increase a little bit the thickness, so 2.036. So we can do a boolean after. I'm gonna copy this one in here to create the offset, so to have the same attribute. And from here I'm gonna promote this to point, so attribute promote from primitive to point and offset. Then I'm gonna create a normal on the points, and after that I'm just gonna create a new wrangle and multiply the normal by this attribute, so v10 multiplied by the offset. So we're just changing the length of the normal, as you can see. And finally we can do a poly extrude, and now we can do point normal existing and just set it to 1. In this case, yeah, 1. And I'm gonna make sure I output back also, so something like this. Then I'm going to create another normal just to get rid of those issues. I'm not sure if I used any subdivisions in here, but I don't think so. So now we can take this and do what boolean subtract, and subtract from this, and we get something like this. So we might need to play in here with the offset. So yeah, in this case we need to play in here. Let's not just reference copy, let's copy. So it's this one. And let's manipulate in here the offset a little bit. So instead of doing like this, first of all, let's copy this step height. And let's do ch ramp offset, or let's just call it ramp, and do it along the offset. Let's copy that, create that, and we can manipulate in here. So in this case, let's have a look at the boolean and get rid of the visualization, and let's do the following. Let's set this to B-spline, increase it a little bit in here. So let's increase it a little bit, and in here we can actually push this down a bit. So something like this should work. Maybe let's push this one in here. Yeah, something like this. And on the boolean, let's make sure we set the first one to surface, because I want it open. And we also need to output the AB seams, which will look something, so AB seams, it will look something like this. All right. From here, we can convert line the AB seams, so convert line, and let's pick the AB seams, and I might need to play in here again with this, so not on this part, but in here. So I'm getting a different result. Let me check. So actually in here we don't want to output the back, or do we? Let me see. So I don't want to output the back, I don't want to output the front, that's the thing. Now if we do the boolean, we will have this open mesh, and we do a convert line. And finally we can come in here and play with this offset. So something like this, let's check. Yeah, that should be it. So after converting the line, we have quite a few points, so let's do a fuse. And I'm gonna fuse this by about 0.236. Let's see. Yeah, that seems to do the trick. Then we have a lot of primitives, so let's do polypet. And now we just have one, and finally let's do a resample. And in this case, I think I only need to reorder the points. So previously we had something like this, and now we have them ordered. Then we can create in here a null, and let's do an add. Let's go by group, and let's do from 0 and endpoints -1, just to close the shape. Then we can do again a polypet, because right now we have 2 prims, now I just want 1, and finally we can do a poly extrude. And let's do global and set the scale to 0. So something like this. Let's just make sure we have some geometry in here. So probably we can go still a bit back and do a bit more. So something like this, because it will be easier for the next step when we do so a polyfill. Let's see if this works anyways. So it doesn't. So let's try instead to play with this fuse threshold and create in here a normal. So we actually need to decrease this. Yeah. So let's also create in here some division, so about 4. And I also want to decrease this because I don't want to fuse them. So 1. So let's try that, and polyfill. Maybe we can try just single polygon and create a normal. And let's say that's okay for now. But in this case it's not, because I actually need quads in there. So let's do the following. Let's change again this to quadrilaterals, and let's try to fix that by decreasing a bit of this. So I guess this will be fine. Let's see the boolean, and let's see. So that should be fine, but I don't want remaining points in here, so let's try again. Something like this. Let's see. Well, we can just add in here an add and remove unused points, so that will be fine. So that's our goal, to have this closed, and from here you can just create a normal and create in here a null. So now we want to unite this shape first. So after this add, let's do a boolean union. And we should have united the points in here. And let's do a polyfill, because we want to convert this to a VDB. So let's do a polyfill and set it to single polygon, that's fine. And from here we can, from this geometry, we have in here, I want to subdivide it, otherwise when I feed it into the VDB it will be again too faceted. So for that I'm gonna create a subdivide. That's why I needed the quads. Now if I do a subdivide we will have something like this, which is not ideal. So what I'm gonna do is create a group, and let's do edges, and include by edges mean edge angle. Let's do a freeze, and let's select in here the group one and increase this. And when we subdivide we will have the smoothness but sharp corners. So let's set that to 3, something like this. And now we can create in here the VTB. So for that, so we have these and these. Let's merge these actually. And this is our geometry. As you can see now it's smooth along the wall, and we just need to make a VDB out of these. But before that we also need to create the door in here, so let's do that next. So let's actually create the door now. For that I'm gonna move in here and create a circle, and make sure I set it to open arc and increase this to 180. 6 divisions will be more than enough, and increase in here to 1.3. Then I'm gonna select the ends, so group range, oops, not this one, group range, group by range. I'm gonna select points 1 and 1 and invert range. Then I'm gonna sweep this, set to ribbon, and I'm gonna change this to the y-axis, and I'm gonna make sure I set this to 0.25 and just set 2 divisions in here. I'm also going to output in here the point call attribute, so point call attribute, which will look something like this, so 0, 1, 2. And from here we can group promote the ends, so in this case it's group 1 to edges, and then I can just poly extrude. And I'm gonna extrude the group. In this case I don't want like this, I want transform global, and I choose a value of minus 2.2, so something like this. Now I want also to extrude, to output the front boundary seam, and then I'm gonna do a group promote from edges to points, so front seam. Then I'm going to just get the middle edge, so I'm gonna do at point call is equal to 1, and I'm gonna set this to points and delete non-selected. Then I'm gonna sort this. So before I sort, I'm gonna just try to add this. Okay, polygons by group. As you can see, it won't work, so I'm gonna do instead of labs sort, so I can do circular sorting, and I'm gonna do it along the z-axis, and I make sure I set it to closed. Then I can convert line, and just make sure I connect the path. Then I still have those groups, I think, so on the points, so extrude front seam. And why did I lost the other group, so the ends group? Let me see, points, group promote. Oh, because I want to save it actually, so let's do the following. Let's create a new name called edges and keep original group. And now we can actually extrude the edges group. And at the end, we will still have those points that we can now polycut. So right now we only have a single primitive, but I want to cut them at those groups. So extrude front seam and group 1. And finally I can do a resample. And let me check in here. I want a length of 0.1 and set this to interpolating curves. If I do subdivision, it will create this issue in here. So if we set it to interpolating, it will look much better. Then we can finally unite this, polypath. And let's do a polyfill, single polygon. Oops, single polygon. And let's blast the curve, which is just primitive 0. Make sure we are explicit. And then we can do a divide. Let me see how many subdivisions I used. So in this case 5. So let's divide these into wood boards. So let's do breaker and do bounding box x the x size and divide it by 5. And in here we can just set it to dot y size so it doesn't create divisions, or you can set an I value. So now let's do unique points to separate them. We can actually, before this, do a clean. And let's do unique points and exploded view. Let's see. Yeah, this should work. And now let's do a value of 0.01, just a little bit. And from here we can quad remesh this. So I'm gonna use the exoside quad remesher, and I'm gonna set the value of 256 and make sure I enable symmetry. Let's get some errors with this. So let's try 100. 256, yeah. And now let's freeze it so you can have access on the file on Patreon. Now let's do a poly extrude. And we can try the quad remesher, but it won't work that well. So 512. As you can see, it will create a lot of problems. Maybe in Houdini 21 it will be better, who knows. So let's do that. Let's use this quad remesher and do a poly extrude. Let's see. I'm gonna use 0.114. Oops. 0.114 and output it back. Now I can do a simple attribute adjust float to play with the bevel. So if I do a bevel, and let's say I set this to exclude the flat edges and do a value of 0.236. And now I want to randomize a bit the bevel. So for that I'm going to use a noise. So let's do an attribute adjust float. No, attribute noise float. And let's do an element size of 0.2 something. And positive. Let's do on the bevel scale by attribute. As you can see, we created that beveling. Now if we do a soften normals, it will be easier to see, as you can see. And we can play a bit more with these, but don't overdo it. You can play with the seed also. So that's fine, that's our door. And now let's continue on the next part. So now that we have the door, we can also create a cutting geometry for the hole on the wall. So for that, let's create an hole in here, and let's do a convex hole. Let's do 2D. Let's do a resample. Let me see what values I use in here. So 0.1 will be fine. And let's also manipulate a bit the shape with a mountain. So mountain, which is just an attribute and noise vector. And let's do a value of 0.08 and an element size of 1.23 and offset of 20.2. Now this differs. Let me see. And make sure we do 0 centered, yeah. So let's play again with these values. So something like this will be fine. Now let's do a thicken. Perhaps to thicken. And let's do one normal. Let's also go both directions. So, oh, I know why. Because I need to remove the Z displacement. That's why it was not working. So let's do a thicken now. And in this case, I want to do it in both directions by 0.2. So this should be enough. And let's create a group. And let's do Procedural. On the primitives will be fine. Let's create a node. And we can just merge the, oops. How beautiful is that? So let's actually get rid of these. So there we have it. And now we can copy this to a point on our geometry. So we actually will need to place a point on the geometry. So let's see, let's get rid of this merge for now. And before we do the subdivision, so let's move this up. Let's create it here and now. And now we need to pick a point to place the door. So let's do the following. Let's create the draw points HDA that we generated, that we created in one of the previous videos. I just want to place a point somewhere around here. And now this doesn't output the normals, so we can do a wrangle and make sure we have normals on solids. Create a normal. So here then we go to UV sample. We can just do UV sample 1, and we want to get the normal attribute. Oops. And by P and sampling P. Let's see if that works, and it should work. Let's see. Yeah, something like this. And now we can do copy to points. And let's see. We actually want to adjust the scale, so let's just visualize this and adjust the scale in here. Attribute adjust float. And let's pick a value that makes sense, so something like this. And we can always go back in here and move this around, maybe decrease it a bit more. And play with the point in here. So something like this. And what else? Now we can split this by the proxy door and invert selection. Now we have the door. But yeah, let's output in here the door. So door. And for this one, this is the geometry we want to cut. So for that, we just need to do a boolean. So let's do a boolean subtract, and we want to subtract from here and with this geometry. Maybe we need to play in here with a pick and don't recompute the normals and increase it. Let me see. So let's do minus 0.23, and let me see. So we actually need a bit less. And let's see if we move it down, it will make a difference. So solid subtract. Let's see in here. So what am I doing wrong in here? Let's see. Subtract solid, solid. That should be working, right? So I'm doing this. Oh, I'm visualizing this geometry, sorry. This should work, as you can see. And now we can come in here and play with the position, and it will automatically sample the normal and align it perfectly. So let's say it's in here. Yep. But we might want to do the boolean not on this geometry, but on this one. So on the subdivided one. That's fine. And from here we can also copy. Let's see how the door aligns. So it might be a bit out. So let's move the point a bit up. Something like this. Oops. And maybe let's pick it a bit more. Maybe not so much. What we can do is just use a transform in here and move this back. So something like this. Of course, we did that mountain on the door hole, on the door proxy, so that's why it's not aligning so well, because if we remove actually that, it will align perfectly, as you can see. But I like that noise, so let's maybe play with it. So maybe something like this. And finally, let's push it down a little bit. Yeah, then we can hide the bottom part. So that's the boolean done. Now let's move into the VDB part. So before we go to the VDBs part, let's play a bit more with these stairs. So in this case, I just want to create some random bevel. So let's do a bevel and ignore flat edges. And let's do a distance of 0.005. And so let's do an attribute randomize. In this case, I'm gonna set it to p-scale and set the minimum to be something like 0.1, between 0.1 and 1. And let's scale the bevel by this attribute. So something like this, and we can play with the seed to get a different result. We get something like this, yeah. Now we can do soften normals. That should be fine. And let's see how did I organize this in here. So let's move this down maybe. Move this one in here. And now let's do a Boolean union between this stairs and the walls. Let's see. Something like this. In this case, I want to do the Boolean between the stairs and this part in here with the door. That's why. That's like that. Now let's do a VDB from polygons. And in this case, I think I'm gonna set a pretty high value. So 0.002. And let's fill the interior and do 0.02 in the exterior band. So we have some space to play with it. Now we will need to merge in here a curve to create the VDB smooth. So in this case is after the first boolean in here. We have this null of the curve. Let's subject merge that because we will need it. So after the VDB from polygons, we will do a VDB smooth STF. So VDB smooth STF, because so why is showing me the viewpoint? Why is showing me this cage? So I just pressed Ctrl T to open a new viewport, and now it's working better. So previously it was showing me the full cage. So now we want to do this smoothing because right here is not uniting well the shape. So let's do a VDB smooth STF, and let's do Gaussian. And we also need to play with the iterations. Let's set it to 6. And as you can see, that will indeed smooth out that part, but will also destroy everything else, which I don't want. So what we can do is to use that curve and do a simple sweep in here. So in this curve, let's do a sweep, set it to round tube. Now let's do 0.025, just a little bit, and make sure we close it because we will do a VDB from polygons. And let's do a value of 0.005, and let's do instead fog VDB. So it's hard to see, but it's there. So now we can load that as a mask, and it will take a little bit. And as you can see, it's working a bit better. Let's make sure we name these. Let's name these actually properly. So mask, and let's do in here mask. So from here, what we want to do is to create yet another smooth for smooth out a bit the door in here, but this one won't be a Gaussian. So VDB smooth STF. Let's do just one iteration on mean. That will help us. And let's make sure we set this to density, and it will calculate again because it will be easier to bind in a volume vault that we will do next. So let's do a volume vault. And this one will be pretty simple. We will bind, we will create a unified static, connect the position to the position. Let's set a frequency of 5 and make sure we do some fractal, and let's add this, and it will disappear, and we will do a fit range and a multiply constant. I'm gonna scale the effect to be only 0.015, and now I can just play in here with a fit range, so I can just increase this. Oh, I need to play with the noise type, which will be Worley Cellular F2 F1. So this one. Now I can play in here just with these values. Maybe play with the offset, but in this case I think I'm gonna leave it like that. So just create some dents on the geometry. That's fine. Let's do a convert VDB. And I'm gonna change this to polygons. And I'm also going to use some adaptivity to reduce a bit the polygon count. So about 0.01. So something like this, and we will have this geometry. And from here, we can merge this with the door. So let's merge this. And we can look at this geometry that we'll need to play around to make it look like wood. So we will do that in the next part. So let's try to finish this. Let's try to make this look like actual wood. So for that, I'm gonna subdivide this quite a bit. So subdivide, and let's set it, for now let's set it to 3. And let's do a point pop. and a normal after it. And in the point VOP, we will try to make this. Let's try to do a turbulent noise. So turbulent noise. Let's connect the position to the position, and let's do in here a constant in the frequency. Let's set the frequency to be 10 on the X and 50 on the remaining. And let's do a displace along normal. I'm gonna use in this case just a small value, so 0.015. And let's do the amount and connect this to the position. But as you can see, this won't work very well because we are transforming this in, we are feeding the world position to the noise, and we actually need this in a rest state if we want to make it look like a stretched noise. So no matter how much we play with this, it won't work. So we need to take a step back and do the rest position workflow. So after this copy, we do the add and the resample. Let's create in here a point and do the sweep. Then we need to make these curves to move them into a rest position. So you can use VOPs, you can use VEX. In this case, I'm gonna use VEX. So first of all, we need to lay them out in a flat position. So we will need the curve view. So we will need the curve view, and we will also need the perimeter to scale them appropriately. So let's do float per will be a prim intrinsic, and we have a prim intrinsic that is the measured perimeter. You can just say add prim num. So that's our perimeter. Next we need the curve view, so we can just use vertex curve param and the vertex number. This is like curve view, so vtx num. Then we can say v at p, it will be equal to set, and the x position, it will be the u component, the u or the curve view multiplied by the perimeter. The y can be 0.0 and the z can be I at prim num. Let's see if that works. And indeed it does. It's actually doing the perimeter. I guess it is. But I want to play a bit more with this, so I want to center them. So for that I'm gonna take this one and subtract the half of the perimeter. So perimeter multiplied by 0.5. Now it's at the center, and for the z position I'm gonna do the following. So z pos. This is not necessary, but just in case you're wondering. So I'm gonna take the prim num, just like I did first, and I'm gonna subtract the amount of primitives, so num prim minus 1, and then I'm gonna multiply by 0.5, so it is at the center, and finally divided by the num prim. So float I at num prim. And if we feed that to our z position, we should have something like this, so everything centered, which I like. So rest. Let's color this. And now we can do the following. You can take this, Control Shift Alt to make a reference copy and do a sweep. And finally we can do a rest. Oops, and use this one as rest. So we will do the same in here. So let's see. Let's do the add and the resample, create the point, do the rest. And it's just 2 lines. Then let's Control Alt Shift drag to create a reference copy and do again a rest in here. Oops. So now we should have a rest attribute on our geometry. And if we move into our point VOP, we still have the same issue. Let's this time increase this to 4. And instead of using P, we can use bind. And let's do rest. And it should be a vector. And if we connect this, as you can see, now we will have this working, and we can play with the offset. So maybe not so much. So something like this, and we have the wood like displacement. So I think that's about it. Now we just need to merge this over the rest. So if we take this and do a merge, and give it a no, move this down, and that's about it. So finally, I'm seeing in here we have some faceting, so we might need to add some more divisions. So I'm gonna let you do that. So because this is already too long, so let's do a skylight. And let's do real-time shadows. Do something like this. And let's create in here a color. It will be something like this. So yeah guys, that's about it. Now you can play around with the setup and do some more work on the door and fix in here the steps. But overall I think it was a nice exercise to play around with procedural modeling. So as always, you can grab the files on my Patreon alongside with exclusive tutorials. And if you like these videos, consider supporting me over there. So let me know your thoughts in the comments. And other than that, thank you for watching, and I'll see you next time.